Here in this case, we are again going to project an object from a tower of height h, but now the angle of projection is theta below to the horizontal. In the previous case, we actually projected, suppose this is the horizontal direction. In case 1, we projected along the horizontal. In case 2, we projected at an angle theta above the horizontal. Now we are going to project at an angle theta below to the horizontal. If you project at this angle, the projectile will take this course to reach the ground. So it will take this course to reach the ground. So what is the velocity after t seconds? So after a while, let's say the object has come here. This initially, if you had thrown with velocity u at an angle theta below the ground, this u has got two components. One is u cos theta in the horizontal direction. The other one is u sin theta in the vertically downward direction. Because this is the angle, right? So this is initial horizontal velocity is u cos theta. The initial vertical velocity is u sin theta in the vertically downward direction. U sin theta in the vertically downward direction. After a while, since gravity acts only in the downward direction, no acceleration in the horizontal direction, the velocity at any instant has got two components. A velocity at any instant will be along the path. So this will have two components. One is horizontal component Vx and the other one is vertical component Vy. The velocity after some time, the initial velocity is u, velocity after some time is v. This v has got two component here. One is Vx, the other one is Vy. Since no acceleration is taking place in the horizontal direction, whatever initial velocity is there, the same velocity will be there even after t seconds. But because initially u sin theta velocity is downwards, gravity which is also downwards, the velocity in the y direction, we know that downward motion is accelerated motion because gravity is acting downwards, v equal to u plus at. Velocity in the y direction equal to initial y direction velocity into acceleration. The y direction velocity equal to initial y direction velocity, which is u sin theta downwards, plus acceleration, which is g downwards into t. If you assume downward direction as negative, Vy equal to minus u sin theta. You remember there we had u sin theta minus gt. Now we have minus u sin theta minus gt because g and u are acting in the downward direction. So you can also assume that downward direction is positive, and that way also you can deal with it. So Vy is equal to minus of u sin theta plus gt. Then the v vector is vx vector plus vy vector, and which implies v vector is vx, which is u cos theta in the I cap direction, plus vy is minus of u sin theta minus of u sin theta plus gt. This negative sign indicates that it is in the downward direction. So it is u sin theta plus gt, its value, but acting in the downward direction. That's what this negative sign says, that the net velocity vector is u cos theta I cap minus u sin theta plus gt into j cap. So the modulus of that velocity v equal to root over vx square plus vy square, u cos theta whole square plus u sin theta plus gt the whole square. Why? Because minus of u sin theta plus gt whole square becomes plus of u sin theta plus gt whole square. So v equal to root over u square cos square theta plus u square sin square theta plus g square t square plus 2u sin theta gt. So you can write this as u square plus g square t square plus 2u gt sine theta. So that way also we can write the magnitude of that velocity, which will be equal to u square plus g square t square plus 2u gt sine theta.